Hey everyone, welcome back. Lesson 16, Electric Potential and Capacitors. In today's lesson, we are diving into the world of electric potential that deals with flow of charges from one point to another. We'll also cover a fascinating device called the capacitor. By the end of this lesson, you will have a solid understanding of electric potential, potential difference, principle of capacitors, and their importance in real-world applications. So, let's get started. You've probably heard the term potential energy before, but in this context, we are talking about potential energy of a charge within an electric field. Electric potential is all about the energy stored at a point in an electric field, and it's closely related to the flow of charges from one point to another. Positive charge always moves from a point at higher potential to a point at lower potential. Now imagine a positive test charge placed in an electric field. The charge will naturally move in the direction of electric field. This behavior tells us that the electric field and electric potential are closely related. In this video, we'll cover electric potential and potential difference. First, let's try to understand the meaning of electric potential at a point. When a charged particle is made to move in an electrostatic field in a direction opposite to the direction of electric field, work is done by an external agency. This work is stored as potential energy of charge in accordance with the law of conservation of energy. So, we can say that an electric charge placed at a point in an electric field has potential energy, which is a function of its position. You can visualize the potential energy of a charge in the field as a scalar function of position, and for a unit charge, call it potential. In simple terms, it means that different points in an electric field would be at different potentials. And if a positively charged particle is placed in an electric field, it will tend to move from higher to lower potential to minimize its potential energy. Here is the formal definition. The electric potential at any point in an electric field is equal to the work done against the electric force in moving a unit positive charge from outside the electric field to that point. It's important to remember that electric potential is a scalar quantity as it's related to the amount of work done, not the direction of the field. The potential at a point is positive when work is done against the field by a positive charge. But if the work done is by the electric field, like when moving a charge from infinity towards a point, the potential becomes negative. Now let's define potential difference between 2 points. Consider 2 points A and B in an electric field. Let's say the electric potential at these points is VA and VB respectively. If we move a test charge Q0 from point A to B along any path by an external force, the amount of work done by an external force is given by WAB is equal to Q0 into VB minus VA. Thus, the potential difference between the points A and B will be VAB, that is VB minus VA, given which is equal to WAB by Q0. We can say potential difference is said to exist between 2 points in an electric field when work is done against the external force in moving a test charge from one point to another. What's interesting is that this work is independent of the path you take. So it only depends on the points A and B, not the route you choose. The SI unit of electric potential and potential difference is 1 volt, which is defined as 1 volt is equal to 1 joule by 1 coulomb. To simply put, 1 volt is the potential difference between 2 points if 1 joule of work is done in moving 1 coulomb of charge between them. Here's another way to think about it. If 1 joule of work is done in bringing a test charge of 1 coulomb from infinity to a point in an electric field, the potential at that point is 1 volt. Note that the potential at a point is not a unique quantity as its value depends on our choice of zero potential energy, which is we have considered here as infinity. However, the potential difference between 2 points in a stationary field will have a unique field. Let's quickly recap the key points we have covered today. The electric potential is the potential energy per unit charge at a point in an electric field. The potential at a point depends on the work done to move a charge from infinity to that point. Electric potential difference is the work required to move a charge from one point to another, and it's independent of the path taken. The unit of potential and potential difference is volt, and 1 volt is equal to 1 joule per coulomb. To wrap things up, electric potential and potential difference are fundamental concepts in understanding electric fields and energy transfer. I hope this video has helped you understand these key ideas in physics. If you found this video helpful, don't forget to like, subscribe and click the bell icon so you can never miss an update. Drop your questions or comments below and I'll see you in the next video.